All right, I want to add a video in between video 3 and video 4 because I came to realize that the flat field I created for you is so huge that it just becomes very difficult to be able to do some things such as transferring files over the internet right now. We're not equipped for that. Notice how big this file is. It's about 218 megabytes. That's just huge. So what I decided to do is go ahead and squeeze in a little video on making your own flat field synthetically. Obviously, we would do this in the event that we, for some reason, lost our flat fields that night or forgot to take flat fields. But essentially, in order to do video 3 on the image calibration, you need to have a flat field, right? So I'm going to show you how I created my flat field. You'll recall I created one for that last video here, and I called it Flatfield Fit. And so I'll show you how to create that. It won't be perfect, but it will certainly be better than nothing. So to do that, I'm going to go ahead and first of all open up my flat field that I did. If I double click on any icon that looks like a PixInsight icon, it will automatically open up the file in PixInsight. And so we give us a second to open. And you'll also recall that anytime we open up a file like this, it's going to look black until we impose a artificial screen stretch on it. In a later video, I'll show you how to make the screen stretch permanent. Right now, we're going to delink it, your button for the auto stretch, and it shows the file that we have. I'm going to also open up, and to open up an additional file, we'd go to open. I'm going to open up a file, one of the original one of the original Lagoon light frames that we took, and and I'll show you how to. I say we'll open it. It's dragging a little bit. So always go to the desktop first. Don't make an assumption that what you see here in this portion of the screen is what it is. Sometimes it may be linked in the wrong folder. I'm going to go again to raw data. I'm going to go to 811 and I'm going to go to Lagoon, and I'm going to select the very first one that we see. Now it always takes a long time to open up these raw files. It has to decode and things like that first. But I just want to bring the two up just as a reminder of the issue with a lot of times when we're shooting with big chips on certain optics. Obviously, the field isn't flat, and what we mean by, let's go ahead and stretch that up. Obviously, the field, we would like to have it uniform brightness all the way across. That way, any light we see is going to be a true indication of what the light is there. Now, let's bring up, remember our tile windows. We can tile these windows, put them side by side, and we can see them. It'll automatically open both windows like that. You'll recall that with our telescope, especially something like the Rasa telescope, the Roe Ackerman, the light in the center of the optic is always going to be more efficient than at the edges. And so what that means is that we're accumulating light at a faster rate in the center than we are on the edges. Some of that is just natural property of the optics. A lot of times it's caused by maybe some cutting off of the light cone on the edges, by maybe some kind of baffling or some type of just decreased image circle. This happens with large chips more and more prominently, and so of course our DSLR, our Nikon, what is it, the D810A, is that the way you say it on a Nikon? Maybe 810DA, I always get the Nikon and the Canon mixed up. But anyway, here it is, and what we're doing is we're seeing here how much brighter it is in the center than on the edges. Now, the object is certainly in the center, so we would expect it to be naturally brighter, but this is just more brightness than it should be. Certainly, we should see these corners being brighter relative to the center. So what we want to do is obviously Flatfield. We misplaced our Flatfields. So I created for video 3, I created a brand new Flatfield synthetically, which is here. And again, it models you can see a real similarity here. It models this extra light that has kind of been accumulated. And the principle, of course, is if I calibrate and I kind of subtract the two. It's not really a subtraction in this case, it's a division, but still, if I subtract the two, and then it should flatten the field. We saw the difference that made in the last image, in the last video, and so here, if you're going to be able to do that, though, you need a flat field. So let me go ahead and show you how I created that. Now I'm just going to leave this one open right here, just so, and I'll refer to it back. But well, actually, I'm a step ahead of myself. Let's go ahead and go to all processes. Let me show you how I did it. There are two processes here that work very similarly. The first one's called automatic background extractor. And it does exactly what you think it sounds like. It extracts the background. And then down here under dynamic background extraction, we have another process that does something very similar. Now, the difference between the two is dynamic means that you have more control over the processes. You might want to do this when you get the hang of it, or in the event that we have an image where we have some really some things that impose problems on an automatic process, and we'll differentiate between those as we learn how to do this stuff more. For right now, I'm just going to choose the automatic background extractor. Now, you'll recall that when any process comes up, I can collapse by clicking on the little bars here. I can collapse each of the sections. Now for this one, all I'm going to do is I'm going to bring up this one and notice that there is a little drop down for correction. Now what this does is that it will allow us to be able to, when this produces the flat field, if I wanted to, I could automatically apply it to the image. I really don't want to do that. I just want to show the result of what's going on and the way this happens. And so I'm just going to leave it to none. So basically, I'm going to choose just complete default settings here. Now, when I have an image open on the background like this, and I have a process box open like this, if I want to apply the process to a very specific image that's open on my background, I can use this little triangle here, and you'll notice if I click and drag it, and it turns into a check mark there. That means that this is actually going to run on the image that's open on my background. So when I have them open, this is just one of the ways I can decide to run a process. Now, again, what this is going to do is it's going through and it's looking at the file, and it's actually trying to determine what is signal, what is noise, and it will actually model that artificial background brightness that we are seeing. And because we didn't, obviously, this scope is so efficient in the center versus the edges, the result of which, now again, it's always dark when we first bring it up, so let's auto stretch it. But notice what we have here. We have essentially an artificial flat field. Now you may ask, well, why not just do this every time? Well, this is highly variable. Quite oftentimes, if I'm going to create it, I will bring it up. I will bring it up into another program. Oftentimes, honestly, I will. These brightness areas of the nebula are affected into this, and so a lot of times what I'll do is I will actually come in and kind of erase all these things. I will make it as artificially bright, or make it more like a flat field before I even run the process. And I think it's more accurate that way. For this, though, I'm just showing you essentially how I created that synthetic flat field by using this process. Now, I should mention to you that I made a mistake. And here's the mistake. I want you to notice that here where it says downsampling factor of 2. Now, what that actually does is that this field that it creates in order to save memory, it actually downsizes it by 50%. And because if you ran the automatic correction in this dialog by choosing something from the drop down, it really doesn't matter. It just downsamples it, it downsizes it, and then it would impose it on the image, and you're good to go. The problem is if I'm going to use this image and save this, I need it to be the same size. Now, one of the things that you can do is as this one is clicked open, and if you look down here in the bottom right hand side of the menu, you will notice where it says W, H, etc. This is actually the pixel sizes of the image. The width is 2464, the height is 3690. Let's go back to the original file, this raw, and notice that it is much bigger. So notice that the difference between the two are essentially half in both of those X and Y dimensions, both the height and width dimensions. So it is downsampled at 50%. So what I needed to do is, because I need this, if I'm going to save this and use it in another process, I need it to be the same size. So what I should have done was come in here and drag this to a 1, meaning don't downsample. Actually create the file that is this synthetic flat that is the same size as the original file. That way, when I do the calibration routine, I have matching geometry, everything is perfect, and I don't have to worry about any kind of errors popping up. And as you can see, that sometimes you can pop up with some errors on calibration, as we saw in the last video, if you're not too careful. Now, so what's going to happen is I'm just doing the thing again, and it brings up. Let me go ahead and just drag it over and click on my nuclear button to see what the screen stretch looks like. And again, there it is. Now notice the difference though in the lower left-hand corner, or lower right-hand corner. Notice the size of the image. If this is blue, that means I'm referring to this image. Notice that I am now 4928 and 7380. Go back to this image, you can see that yes, it is the same size. So that's good. That means that when I should be able to use this in a calibration move, and it will be all good. Now, here's the thing though, you'll recall that I had to actually save that file to use it. I saved it to the background or the desktop of the computer, so we have to save this one if we're planning on using it. So here we go. We're going to save as. Anytime I want to save a file brand new, I'm going to go back to my desktop and I'm going to determine where I want to put it. In this case, I'm going to go ahead and put it on the desktop as well, so I don't have to click in any more folders, but I do have to, 2 additional steps is I have to give it a name. In this case, I'm just going to call it Practice Flat. To differentiate it between the one that's already on the backfield that I used. And then notice that down here, and do not make an assumption here where it says files of type, make sure that you do have fits selected. We're working in fits. It's our default thing that we are going to use in PixInsight, and that's the way it will be. I'm aware that PixInsight also has another way of doing it that's more recent, that may be better. Its own file, proprietary file format. I don't have that much experience with it, so I don't even know what it's called. But I'm just going to use. I'm just going to continue to work in fits until I see a reason to use it myself. So here's the check. Make sure it's in the folder or on the desktop or wherever you want to apply it. Make sure you give it a name, make sure it's a fit, and then you can click Save. Now, it will bring up this one more dialog. It says it's going to sample in 32-bit IE. Well, don't worry about all that stuff. Just say OK. It will usually, on fits, default to the one that the file format you want. So I'm just going to say OK. Now, it takes a second, but you'll notice that it is writing the fits image. And once I've done that, I can close everything up. And that's what I'm going to do. I'm going to close everything, and you'll recall that if I click on this little yellow minus sign, I can actually minimize it so I can see the background. Remember, it puts the icon for it so I can get it back just like that. But anyway, I can just bounce back and forth. Now notice what happens, and sometimes it leaves these little windows open. No big deal. Now you may be, well, where did it go? I've got this little sticky I'm going to get out of the way. Notice it's kind of hiding behind that. Now I knew that, but be aware that if you have other windows open on the desktop, some things like that, sometimes it will it will save to the desktop or to where you can't see it. So I'm just going to drag it right here, and there you go. There's a practice flat. Now let's open it back up and let's see. You'll recall in video 3 what it looked like when I ran an image calibration on that image. So let's do the same thing. Let's now do it with, again, don't make an assumption. Go to the desktop, go to the raw data. Let's grab that Lagoon Nebula file and let's apply a calibration, a flat field that we just created to the image and see if it does improve our image much the way it did in the other video. And so now that you hopefully know how to do this synthetic, the made-up flat field process, hopefully you'll now be able to do this yourself and be able to practice with me. Again, this is not the ideal scenario. We want to take flat fields when we shoot them. We want to be as accurate as possible, and it's just much better to do it this way. This is or to do it the way we're supposed to. This is just a complete workaround of that will improve our image, but not necessarily help us in any other way. By the way, I opened that file up. I probably didn't need to, and let me show you the reason. I'm going to go to All Processes, and I'm going to go to Image Calibration, as we would always do if we want to calibrate an image. But just realize that it's not going to calibrate unless it's actually added to this list. So even though I open this up right now, I still have to put that same file in the list. So we're going to do that. We're going to come to Desktop. We're going to go to Raw Data. We're going to go again to our Lagoon Nebula folder. I'm going to grab that first image that we just opened, and there it is in the list. So this tells us that this is the image we're going to calibrate. It just so happens to be I have a copy of it open on the background too, so that way you'll be able to see the difference in the two. You'll recall that on image calibration, we can do an output file here, and we can set up an output directory where this will occur. There is a way to do it to where I can set it to where it will overwrite the existing file right here. What that will do is when I run it, it will actually open it up for me to see what it looks like. And in this case, I'm going to go ahead and click that. Generally speaking, don't ever do that. What you would do is you would set up a directory to be able to save that new result, and obviously you'll recall that it saves as an _C, meaning it will have been calibrated. But what I'm doing here is I'm just saying, you know what, I just want you to open it up on the screen because I have no intention of using this file in the future. So anyway, the only thing I do is make sure my target frame is selected. In this case, usually output directory, I would determine it, but I'm just going to overwrite the existing file in this case. And now I'm going to come down. I don't have a bias, don't have a dark. So for the most part, that will usually be true with our DSLR images. And then I'm going to come to my master flat, and I want to apply the flat that I just created. So I have to go, obviously, and select it. I'm going to select this folder, and I am going to go to my desktop and grab it. So there it is. I go to open, and the fact that it's written out here in this little box, this white box, tells me it is selected and ready to go. So I'm just going to push the calibrate button to tell me that I am going to actually use this file in the calibration, and then I am going to, in this case, apply it globally. And what that will do is it will run through the calibration process on the single raw frame that we talked about. Notice here, if I follow the process, sorry, I drug a little far and it opened up the View Explorer. I didn't want to do that. Hopefully it'll go away. But you can see in the background, once it goes away there, you can see the process console still running in the background. This computer's a little bit slower than the computers that we run, but anyway, it is what it is. So there it is. We're still on target frame 1 of 1. And we'll see. I am shooting this video at school, so Hopefully, I won't have a kid run in between classes. You might have heard the bell ring, and so not really a bell, but a buzzer. All right, takes a while again with these raw images. When we go to the calibration, it has to decode it and take a little bit of time on each of these things, and which takes more computer power. This computer only has 4 gig of RAM, which is nowhere near what it needs to be able to do these types of calibration frames. This computer, if I do more than 2 calibrate, or if I do a flat field on more than 2 frames, it pretty much locks up the computer and it's just done. Our own computers are Macs in the workshop. Notice, by the way, it did it and it went away. You'll notice it did work. Now, and if I go back, well, apparently, let's see, it should have opened. It should have opened and done it to. I just messed that up, I believe. Override existing files. I guess I'm gonna have to. Now this is going to show my ignorance here. I thought that would have opened up a version of the file, that I could see, and it didn't. So let's go ahead and do this. Let's just set an output directory real quick, where I'm going to choose my desktop, and I am going to actually make it write the file again. So I have to go through this process one more time. This time I'm going to force it. Yeah, can't drag it. Wrong button. I have to. I'm going to do this again, and so that and it's going to create the file this time on the desktop, and I'll have to open it from there. A little glitch there. I got to figure out the reason why that did that. Usually, what that does is that if you're working on an image, it overwrites that image. Now, I have a sneaky suspicion that what it did was it might have overridden the existing file on the computer, which would not be good. So so anyway, if that's the case, then what I'm going to just do is I will rewrite the file and do it that way. So I will do that here in a minute. As this is coming up, let me see what's going on. I have a student that just walked in, and so I'm trying to motion to her that I'm shooting a video right now. So a little bit more time on this. We'll see what's going on. One of the things about I'm creating these videos in QuickTime, and there's no real way in QuickTime once I have an interruption, I have to basically start all over or figure out a way to save the files in multiple sections and then use another piece of software to stitch them together later. I could certainly do that, but anyway, it is a little bit of a pain. Let's go to the background. Let's open up and see if that file did actually work. Go to the desktop. You'll notice here it defaulted and then saved that file right there. It's on the desktop. As we would expect, and I'm going to go to open it, and let's drag it to the side, and if it worked right, let's go ahead and screen stretch it, and if it worked right, then you'll see it should be flatter, the result of the flat field, and certainly it did. You can see how this image is much more uniform across the entire scene. It's definitely not perfect. There is an amount of luck here that went with doing this synthetic. Again, when I create a synthetic, I normally would kind of use, I would honestly use Photoshop to take the original file and kind of erase some of the signal areas, the brighter areas. I kind of flatten it myself a little bit before I would run this routine. I used to create these all the time in Photoshop, to tell the truth, which is another way to do it. But in the event that I ever needed such a frame. But generally speaking, there it is. I was able to show you that, hey, the synthetic flat field that I created in automatic background extraction does serve its purpose here, and it does definitely allow us to calibrate so that we can see the original detail of the image better than the non-flattened image. So use this knowledge, create your own flat field in that case, and then go back to video 3 and see if you can make that work for you. Again, watch these videos over and over again. Make sure the good thing about videos is you can pause them and you can have some pretty good success just by repeating it and watching it over and over again. Hope it's beneficial to you. Thanks for paying attention.